This is a lesson summary video for the task titled All for One, One for All. This is a solidify understanding task. The purpose of this lesson is to solidify the understanding that the solution set to a system of inequalities represents the set of points that satisfy all of the inequalities simultaneously. Things to remember. The shaded region of the coordinate grid represents the solution set for a system of inequalities. A solid boundary line indicates that all points along the line are part of the solution set, and a dotted boundary line indicates that all points along the line are not part of the solution set. So for this graph, remember Carlos and Clarita are wanting to have a business where they board cats and dogs. So the first two constraints that we dealt with was the amount of space that they had and their startup costs. So if we look at just the space to start off with, per cat it required 6 square feet of space and dogs required 24 square feet, and they had 360 square feet to work with. And then for startup costs, it was $32 per cat and $80 per dog, and they had $1,280 to work with. So if we're looking at points, and X represents the number of cats and Y represents the number of dogs, if we look at the number of points let's just start off with the space. The points that are here in this region, this like peachish, orangish color right here, these would be the number of cats and dogs. So if I stop on a point, it's about 35 cats and about 5 dogs. That would meet the requirements for the space, but it's not meeting the requirements for the startup costs. It's too expensive. So all of these points in this region only meet the requirements for the space, but not the startup cost. In this region over here, you can see that it's shaded in this purplish bluish, but not shaded with the orange part. So this would be a place where it meets the requirements for the startup cost, but it's not meeting the requirements for the amount of space. So for, well, it doesn't really make sense because it's negative, but if we could have negative 8 cats and 18 dogs, then there would be enough money, but not enough space. But again, it doesn't really make sense because we can't have negative cats here. So the part that's in the middle, where both of the inequalities are shaded, this represents the solution to this system of inequalities. So the double shaded region. So for example, that's about 10 cats and 5 dogs. That would be an okay number of cats and dogs because they have enough space, because it's in the orange shaded region. And they have enough money because it's in the blue shaded region, and it is in this double shaded region. So any of these amounts. Now that also includes like if it is on the line. So solid lines, and these are solid lines because it can equal this amount of space and it can equal this amount of money. So this one would cost for 40 cats, that would be exactly $1,280. That does meet the requirement. So if you wanted all cats, 40 cats, that is a solution to this system of inequalities. The same with dogs here. So if I'm at 15 dogs, that is on the line for the space. So you're using all your space for 15 dogs, and you do have enough money to do that. So again, the solution is the double shaded region. All right, so in the tasks earlier, we added a constraint for feeding time and for pampering time. And now we have a lot of inequalities. And we have regions that satisfy some of the inequalities and don't satisfy others. But in this region here that's being shaded by all of the inequalities, that would be the solution to the system of all 4 inequalities. So you're looking for all of the regions to be shaded. The feasible region is the set of points that satisfies all of the inequalities. So if you were to give a recommendation to Carlos and Clarita about how many dogs and cats they can have, then it would be a number of cats and dogs that would be in this region. So for example, 20 cats and 5 dogs would work. So the things to remember, this shaded region is where you find your solutions. So if you have multiple inequalities, so you have a system of inequalities, you look for the part that's shaded by all of the inequalities. That's where you will find your solutions. If the point is on a solid line, it's included in that solution set. But if a point is on a dotted line, then it's not included as a part of your solution set. All right, that's it for this video. Thank you for watching.